So we now move on to incident solar radiation analysis. Okay, now in the previous session, we were purely looking at whether a part of a building or part of a site, whether it was in sunshine or whether it was in shadow. We were not looking at the actual quantity of light or the quantity of energy incident on those buildings. In this session, we now start to look at how we can simulate and analyze the actual quantities of energy incident on our buildings. Now, this is just a slide from one of my 6843 lectures. Now, what I'm going to do, I have another lecture on which is purely about the physics of daylight. Some of the students in this class are taking that module anyway. But what I'm going to do, I'm going to put that lecture on MOL for 6780 so that those of you who are not taking the other lecture course can have a look at that, because that will give you some useful understanding about the physics of daylight. Okay, but this is just a quick extract from that, and really I'm just putting it in to show the huge difference in the quantity of daylight in the UK across the year. So if, for example, if we go to our midday, this top red line is our midday figure, and as you can see, in January we're right down at this level, which is about 6 kilolux. We go all the way up to the top here, and roughly we have about 3 times as much energy in summer as we do in winter. And the important thing to remember is that illuminance is directly proportional to solar radiation. So in other words, the quantity of light you get is directly proportional to the quantity of energy. So they're completely related. So what it means is if you're simulating solar radiation and you're perhaps interested in terms of heat gain, you're also getting metrics that can help you understand the quantity of light. Okay, so they are directly proportional. Now if we move on here, what this graph is just showing us very quickly is showing us the range that we get in the UK in any particular month. So if we look at the global horizontal, the green bar, this is telling us how much energy are we getting horizontally from the sun. As you can see, in June, that is still a huge range. And the reason is very simple, because we have a lot of clouds in the UK. Okay, so on a cloudy day, your illuminance level might be right down here at sort of 5,000 lux, and then on a sunny day you could be right up here, peaking potentially up here at sort of 90,000 lux. And today's not a bad example because it's pretty dark out there today. You know, I went back to my office in the break and I almost had to switch the lights on because it's, you know, we've got such dense cloud cover today that it's really quite dark. But then, you know, if this afternoon the sun came out, probably unlikely, but if it did, you know, it might be 5 times, 6 times as bright out there. So that energy range that we get from the sun in the UK, it does vary hugely throughout the day and throughout the year. Now, in other climate zones, it's not the same, because in other climates where you have less cloud cover, that sun intensity will be much more constant throughout the year, or, you know, at a given time of the day you can rely on that sun's energy to be more constant. Now, the reason that is important for us is because what we need to do is we need to simulate that energy level from the sun over a range of time. Okay? And it means that you can't, it's not very meaningful, particularly in the UK or in Northern Europe, to take a moment in time and say, for example, to look at 20 past 11, 20th of October, what's the energy from the sun? That would give you a figure, but that figure would be dramatically different in June or even at a different time of the year. So in today's session, we're going to be showing you how we are simulating over a range of time. Okay, I'm just going to go back out. I've opened Vasari. I'm going to drop back out of Vasari, and we'll just start from the beginning. So, solar radiation, at the moment, we are demonstrating that using Autodesk Vasari. Now, I spoke to Autodesk last year, and they said that they would be integrating these tools into Revit. Okay? They were lying, because they haven't. Okay? I was hoping they would, because really to have to use this other package, which is slightly different, you know, it's kind of slightly irritating. But at the moment, there's no way of doing this kind of analysis in Revit. You can do it in Ecotect, but as we've talked before, we're not promoting Ecotect because it's kind of on the way out. Now, I suspect by next year we won't be using Vasari anymore. The software will have moved on, and I'm pretty sure this will be integrated into Revit, or Autodesk are going to reinvent Ecotect as an updated package. Okay, but for now, we'll do it in Revit. In Vasari, sorry. I rewatched one of my videos yesterday, and I did notice that I keep calling Vasari Revit. Okay, and I was confusing myself. So, generally, if I'm talking about Revit now, I mean Vasari. Okay, sorry about that. Okay, a few practical things. Project Vasari is available as a beta version. It's version 3. It's free to download. If you just Google Project Vasari, you can download it. Okay. What else? The great thing about Vasari is it will open Revit files natively. So you don't need a separate file. Okay, that's really useful. Now the other thing that a lot of people like about Vasari is it's kind of like Revit Lite. So it sort of looks very much like Revit, has a lot of the tools the same as Revit, but it's a bit of a lighter interface. There's a bit less going on. And a lot of people actually like it as a sort of front-end design tool. Now I haven't got time in this course to really cover that, but what you will see in Vasari is that a lot of the tools are exactly the same as the tools that we've been using in Revit. And you know, it's up to you. If you prefer to perhaps start your project in Vasari, that's fine. And you can, of course, open a Vasari file in Revit. So they have that fantastic interoperability that you don't need to export, you just open the file. Okay? So let's just go in. I'm going to open this pre-made file here, which was made in Revit. So this is a Revit file, but I'm going to open it in Vasari. And while it opens, sometimes it will give you a little reminder to say, this file was made in Revit, and therefore it won't have all of the functionality when you open it in Vasari. I think when you open it for the first time, it gives you that little warning just to sort of remind you that you're not in Revit now, you're in Vasari. Okay? And as you can see, it looks very similar to the Revit environment that we were in an hour ago. Okay? Very, very similar. All of those tools that I was showing you before in terms of the view cube, the different views, are all exactly the same. Okay? So here's our properties, exactly the same as Revit. Here's our project browser. I've got these docked slightly differently, but it's the same. Down at the bottom here, we've got all the same view settings, exactly the same as Revit. Okay, so everything that we were doing in the previous session in Revit, you could choose to do in Vasari if you wanted. And equally, some of the modeling that we'll actually look at in the next session, you could do in Vasari. Now, my preference I find it easier just to work in Revit. Rather than trying to learn two packages, I would say for most of what you do, it's probably easier if you just stick to Revit. Just use Vasari for particular simulation exercises. Okay, so that's what we're going to do today. We're not going to model anything in Vasari. We're simply going to use the solar radiation tools in Vasari. So let's get straight onto it. There's our view that we've already created. As before, I've renamed it solar analysis. We can rename that again. And let's go up to the top, and we have the Analyze toolbar. Click on that, and we get now some analysis options, some analysis tools. And interestingly, the energy analysis tools are available in Revit, exactly the same as Vasari. The wind tunnel and the windrows tools, you can access those in Revit through a plugin called Falcon, which is an experimental plugin, and I've found it doesn't work very well. Okay, but those tools potentially are available in Revit, and today we're going to use the solar radiation tools, which are not available in Revit. Okay, not sure why not, but they're just not at the moment. So let's click on that, solar radiation, and we go straight into some options here. I'll just pull that over to the side there, and let's have a quick look here at some of the options. So first thing, sun study. Let's click in that little dialog box there and have a look. As before, most important thing is that you have the right location. So just check that. It's asking me to sign in. Why it's doing that? Probably can't remember my password now. Okay. I mean, it's something, it did sign me in there. It's something you will notice later on when we're using Revit for rendering. You do need to be signed into your account because you're using some of the cloud services which they charge for normally. You do need to be signed in. Okay. So it's taking me again into a weather choice of weather stations, and I'm just going to have the closest one, okay, which is this one. You could change to a different weather station, but there's not really much point. Okay, Sheffield, South Yorkshire, so that's fine. Now, next thing is, what range of time of the year do you want to simulate? And that's quite an important choice now. Now, you could study the entire year. Okay, that might be useful. You could study a particular season. And the kind of questions you would need to ask yourself now is, what am I using these results for? And generally, in the UK, you've got probably 3 parameters that you're kind of interested in. So the first one is about daylight. Am I getting enough daylight through my windows? Okay, second one, could I use the sun's energy to warm my building? And thirdly, am I getting so much sun energy from the sun that my building is overheating? So 3 different parameters. Now the first one, getting enough daylight, would be relevant throughout the whole year, because you would want daylight throughout the whole year. The second one, about getting some passive heating from the sun, you may decide, well, I'm only interested in that in winter, or perhaps I'm only interested in that in the morning, because what I don't want in the middle of summer is lots of heating in the afternoon. So the third one, about overheating, again, you might decide and say, well, in winter I'm not worried about overheating because the air temperature will be cold enough outside anyway. And so you need to kind of consider what are you interested in? Why are you studying the radiation? Now I'm going to just start with something simple. Let's just start with a winter solar study. And I go to one of these presets here, and what I'm going to do is duplicate that so that it becomes our own unique setting, not one of the defaults. So let's call it Winter Solar Study. Let's call it Arts Tower. Arts Tower 1. Okay, so it's now our unique setting. And it's set at the moment to simulate from 21st of December through to the 19th of March. Now I'm going to change that. I'm going to change that from October through to March. So I'm going to take that sort of what's that? It's about 6-month period of winter. And let's have a look at that winter period. And let's have a look. Let's have a look at that from 9 o'clock in the morning through to 5 o'clock in the afternoon. And as before, let's have a look at that per hour. And again, as before, we're not bothered in that shadow at ground plane. So we've got our settings. This is our winter study. So we'll hit apply on that and we'll hit OK. So, just to recap, we go back into our solar radiation dialog box, and it is our winter solar study for the Arts Tower. Okay. Let's go down here now to the display settings. Okay, first one is type. So, we've got cumulative, average, or peak. Cumulative will add up all the energy over that period and will give you the total amount of energy incident on your buildings. Average will give you an average per day. And peak will purely record what's the highest level of solar radiation during that period. Now, normally, for the UK, cumulative is often the most important one, because it will give you that total energy over that period. Okay, units. BTU is a British thermal unit, and we don't use it. Okay? It's used in the United States, but in the UK we don't use it. It's not a metric unit. Although, British thermal unit, you might think it's used in Britain, but no. We use kilowatt hours. Kilowatt hours per meter squared. We don't use the other one, watt hours per meter squared. It's just too small a unit. So kilowatt hours. And what that means is it's a unit of energy, and it's the amount of energy. It's a 1 kilowatt, 1000 watts, incident for 1 hour. Okay, if you Google it, you can convert that to joules if you want, or kilojoules, but kilowatt hour is a typical unit used in the UK for building energy. Right, style. So these are display styles. And just to start with, I'm just going to drop to the solar radiation default. Not sure what that was. Okay. So I'm just going to use the default display style initially. Automatically update results, you can leave that checked, and whenever you make any changes it will automatically update. Okay. We've then got analysis accuracy, and all this is doing is saying, well, how detailed do you want me to analyze these buildings? Do you want me to take readings every meter, every 2 meters? How fine do you want that analysis? Now, to be honest, I normally find if you leave it in the middle at 50, it will work perfectly well. But you can play about with that. Okay, what we now need to do is tell it which faces to analyze. So, which of these buildings are we interested in? And what we do is we click on the little arrow here, and you can probably just about see that it turns grey. It can be quite hard to miss that, but it's turned grey. And now, if I go over to the model, when I hover over the different faces, it puts a blue outline around them. So I'll select that, and what it will do is when I hover over further faces, it's showing me the little plus sign, so it will add any other faces on. So I'm just going to add a selection there. So let's say at the moment we were interested in looking at these surrounding buildings, and maybe the purpose of this study was to just check that we are not compromising the energy levels hitting those surfaces. So I've selected a range there. Okay. Now this next step is it's quite easy to miss this. You need to go back to your arrow here and tell it that you've finished. So you've finished selecting faces, and it will run the simulation. Okay. So it's run a simulation of the energy hitting those faces across that period, so across that sort of 6-month period. I just close down that dialog box. It's used the default view settings, which is what these colors are. The legends appear sometimes quite small. Now I've opened this, this is a sample file, so it's actually in metric. Okay, so possibly the legend was there, but I just hadn't seen it. Okay, so you get this legend, which is explaining what you simulated. Now you also need to play about with your settings down here a little bit, because I've got the ambient shadows on. Okay, that makes it a bit cleaner. Okay, so I'll go back to the UK model in a moment. This is a model in California, but just to explain what you're getting here, you're getting a color code, and that color code is telling you how much energy is incident on that building face, and that depends on the period that you've specified. Now in this example, they've done it for a single day. Okay, so let's just quickly run that again over a period. Let's do let's do multi-day, winter. Okay. Okay, so we've rerun that. Sun study, start time 21st of December, 10 o'clock, and it's running it all the way through to the 19th of March at 4 o'clock. And I'm just going to run that again, change the units, kilowatt hours. Okay, so that's more what we were looking for. Okay, it's a simulation in a unit that is meaningful to us, kilowatt hours, and you can see what we're doing. We're getting here the blue down here is 5.8 kilowatt hours per meter squared, and then if we go all the way up to the bright yellow, that's 243 kilowatt hours per meter squared. And if we just zoom out a little bit there, I'm just going to switch the shadows off for clarity. You can see the kind of distribution of energy you get across that building. And obviously down here, where we're getting a lot of overshadowing from the adjacent building, we're getting much lower levels of light energy. Whereas up here, where we're probably never overshadowed, we're getting hugely greater energy levels. So now, as a designer, what you could start to think is, well, this is telling us something about our windows and about our shading. Because clearly that point down here in the purple, which is getting an energy level of about maybe 50 kilowatt hours per meter squared, will have a very different requirement in terms of windows and shading from this yellow patch. And if you remember, there was a quote, those of you in my lectures on Friday, I gave you this quote from our visiting professor, Clark Brockman, who was saying that sustainable buildings should look different east, west, south, north, because those facades are getting completely different levels of energy and light from the sun. And I think this is the power of this kind of level of simulation, that clearly that facade there is not getting the same level of energy as that facade. So if you take a building like this, where you give every facade the same glazing strategy, well, clearly that facade is getting a hugely different amount of energy and light from that facade. And hence we get problems with overheating, with rooms that are too cold. So very, very powerful tool for that kind of level of simulation. Now what I'm going to do, we've got a little bit of time left. I'm going to show you some of the different settings you can use, and then I have uploaded a little video onto Mole which just takes that a little bit further with some more sophisticated tools for altering the settings. Now I'm going to just, rather than quit out again and start again, I'll just proceed with this file. Hopefully it will work, because I've not tested it, but we'll just continue with this file for now. So we'll go back into our solar radiation, and let's have a look now at our different styles. If we go to an Ecotech style, those of you who have used Ecotech before, it just changed it to a more sort of Ecotech style where we have a grid. Okay. Oops, sorry. If we then go back and we click on the, sorry, let's do that again. Click on this little dialog box here. This allows you to create your own style. So if we go here and we create a new style, and you get this choice, how do you want it to look? How do you want it to report the information? Now, what I find most useful often is to use the numbers, so the markers with text. Okay, let's just call this, we'll call this Style Arts Tower 1. Okay, and what this now will do is it will actually put the actual figures onto the image. So you have this, what kind of marker do you want? It's a circle. What size do you want it? I'm afraid I've opened an American file, so I'll leave that in inches for now. Okay, you've got some different sizes for the text. Color, you can play about with the color that you want it to show. And then again with the legend, that little key, you can alter the settings on that. So, okay. Let's select our Arts Tower style and rerun it. Okay. So, oops, sorry. Arts Tower style. Close that. We zoom in. Numbers didn't appear. Let me just try that again. I can't work with those American units. Let's just edit our style. Text labels. Ah, no. You have to, sorry, by default it does not show the numbers. Slightly annoying. You have to change it here to show all. Okay, show all. The text size, I've no idea what 1/4 of an inch Arial means, but let's just try it for now. Okay, so you've now got the actual numbers. If I just close that. They're probably a bit too close together. But what this now means, if we just zoom in a touch, is that you can actually not just have that sort of color-coded key, but you can actually have the the exact figures of radiation across those facades. And that's very useful. Now, as a designer, you could use that immediately to perhaps inform window size, to inform shading design, all sorts of parameters in terms of those facades. Very useful. Now, another kind of study. Have we crashed? I'm not sure if it's crashed. It can be a little bit unstable, Vasari, to be honest. Okay. What I'm now going to do is I'm just going to come out of that. The other thing you can use this for is if you're considering putting photovoltaics, so solar panels, onto a building facade, then again, this can be very powerful, because this time if we select our roof surfaces, just use tab there to, if you're struggling to get the correct face that you want, if you press tab, it will scroll through different faces. Okay, so I'm just going to select some of our roof surfaces. Try to. Come on. One do. Okay. So I've selected some of our roof surfaces there, and let's just run that simulation again. We must finish here. Finish selecting faces. Okay. That will rerun the simulation. And this can be very useful. We just zoom in there, because it now enables you to position those photovoltaic panels on the part of the roof that is getting the most energy from the sun. Now, in this case, it doesn't appear to be a huge sort of distribution across those roofs, but you could imagine a condition, particularly in the UK, whereby you were getting overshadowing from an adjacent building, and those photovoltaic panels are not going to receive enough energy. Okay, so that is also a very powerful tool. Now, what I would encourage you to do is play about with these view settings and watch the extra video that I've put onto Mole. I'll put this video onto Mole as well, and I'll put the one from last year's which didn't have that crash, and didn't mean we had to move to California. Okay, so you can view both of them. I'm not going to re-edit this one. That'll take too long. Play with those. Play with those settings. You can start to get these outputs to look exactly as you want them to look. All right. I mean, I'm doing it very quickly here, but you can really start to get some quite precise information out of it. Now, in terms of exporting images, it's very similar to Revit. We go to Export, Images and Animations, Image. Okay, similar again, visible portion of current window. Let's just check where we are putting it. So let's just put it in there. Let's call it, this is California, isn't it? Okay. Image files, save. And as before in Revit, it will default to this very low resolution, so just watch out for that. I'm going to put that to quite high resolution. Let's try 3000 pixels wide. Okay, JPEG quality, yeah, okay. Okay, let's just find that. California. So there's our export. I've left the sun on there. And what you find is if you export with high enough resolution, it gives you the ability to zoom in. Okay, and you can see your key at the same time. Okay, so that's quite straightforward. Now there's just one other function that I'll show you, then we'll have a break. If we go back into our solar radiation, if we go into our output here, you've got this export. So you've got this export option at the bottom. Now, this is really beyond the scope of this course, but what this allows you to do is it allows you to export the actual data from your simulation. So not the image, but the actual data values. Now you might think, why would you want to do that? This becomes really useful if you're starting to work parametrically, or you're starting to work with adaptive components, whereby you're modeling elements on your building which are changing shape, changing size, based on defined parameters. So, for example, excuse me, imagine you were designing a shading system for this facade here. And what you can do in a BIM environment, whether you're in Revit, whether you're using something like Rhino, Grasshopper, you can create elements that will take their dimension from a parameter. So let's supposing you're designing a shading device on this facade, you could create that component and you could tell that component to take its depth from your figures that you're outputting here. Or another way to do it would be to say, for example, have a window size, and the width of that window would be based on the parameters that you export from your solar radiation. So if we export that, it will export as a CSV file. That's a comma separated values file. And that is a kind of data file which you can open in Excel. And you can also bring that data into Grasshopper, into Revit, into Dynamo, into various other softwares. So let's just California data. So we save that. If we go back in and find that, if we try now to open that with Excel, it won't, I mean, it's not going to mean much to you on screen, but just to show you that it is exporting the raw data. So what you're getting now is for every one of those points, you're getting the coordinates and you're getting the insolation value, the energy value. Okay? And if we just scroll across those, they obviously vary. And, you know, if you're interested in that kind of work, and if you're particularly anybody who's taking the parametric module in semester 2, or in semester 1, the BIM module in semester 2 with Dr. Sungshen Wang, he is very interested in starting to take this performance-driven data and use it as a design generator. Okay? For this module, we're not touching that. But I think it's just, you know, important to perhaps explain to you how you can start to output that data. When you look through the example reports that I've put onto Mole, what you see is what most people are doing. If I just zoom in here, is they're using the data that they're generating in Vasari, they're using it to make informed design decisions. So they're making decisions about whether it's too dark, whether there's too much overheating, whether the windows need to be bigger, whether it's a good place for photovoltaics. So they tend to use it in a more intuitive way, not in a sort of parametric way. And that's perfectly fine for this module. Okay? So, I've kind of rushed through that a bit because we had that crash. But just to go back into Mole, and show you, if you go into lecture resources, and you go to instant solar radiation analysis. What I'm starting to do now on MOLE is add additional resources. So, in other words, in addition to the presentations that I give, I'm adding some useful videos. Now, often these are Autodesk videos or particular sort of Revit, Vasari experts. And sometimes these just add another level to the explanation. So this one talks in a lot more detail about working with those legends in Vasari. Okay, and you can watch that, and what I'd encourage you to do is watch the video, sit at home, try it. Okay, and I will start doing that now. That you'll find there's a lot more content on MOLE than I'm delivering. Now, it's up to you. Some of it you'll be more interested in, some of it less, but I'm just pointing you to some useful resources.